at 1300 hours on July 6, 1944. 16 Avro Lancaster bombers of No. 617 Squadron climbed through clouds over the English Channel. Each aircraft carried a single weapon, 12,000 pounds, 21 feet long, cast from a single piece of high-tensile steel, Barnes-Wallis Tallboy earthquake bomb. The target lay 165 kilometers across the channel, a limestone hill near the French village of Mimoyeques. Intelligence designated it Construction Project 711. The Germans called it Wiese, meadow, inside the hill, buried 105 meters beneath the surface. 50 guns were under construction. Each gun was 130 meters long, 430 feet. The barrels were inclined at 50 degrees, all aimed at London. The Lancasters approached at 20,000 feet. Wing Commander Leonard Cheshire marked the target with red spot fires. The bombardiers released. 16 tall boys fell. Terminal velocity, 750 miles per hour. The bombs penetrated the chalk hillside. They exploded deep underground. The shock waves collapsed tunnels. One drift caved in completely. 300 workers, slave laborers from occupied countries, died instantly, buried alive. The V-3 supergun complex at Mimoyeques would never become operational. Hitler's plan to bombard London with 600 shells per hour had been destroyed by 16 bombs. This is the story of the V-3, Vergeltungswaffe 3, Vengeance Weapon 3, the London Cannon. A weapon so ambitious it defied engineering limits, so complex it required revolutionary propulsion systems, so large it had to be built into a mountain. A gun that could fire 140 kilogram shells across 165 kilometers. A weapon designed to fire every 6 seconds for 12 hours daily. 50 barrels delivering sustained bombardment that would reduce London to rubble. Except the gun barely worked. The shells tumbled in flight. The barrels wore out after 25 rounds. The multi-charge propulsion system malfunctioned constantly. And before a single operational shot was fired, Allied bombers destroyed the installation. The V-3 became the ultimate German wonder weapon that never achieved wonder. The narrative begins not in 1943, but in 1880, in Philadelphia, when American arms expert Lyman and his partner Haskell tested a multi-chamber gun at Frankfurt Arsenal. The concept was elegant. A conventional gun fires a shell using a single propellant charge in the breech. The explosion accelerates the projectile down the barrel. Maximum velocity is achieved shortly after firing. The shell then coasts. Friction and air resistance slow it. The multi-chamber concept added secondary charges along the barrel. As the shell passed each chamber, the charge would detonate. The shell would receive additional acceleration. Velocity would increase progressively. Muzzle velocity would far exceed conventional guns. Range would be extraordinary. The Lyman and Haskell prototype failed catastrophically. The expanding gases from the breech charge moved faster than the shell. They ignited the auxiliary charges prematurely before the shell arrived. The premature detonations created pressure waves that slowed the shell. Sometimes they destroyed it completely. The gun did not work. The concept was abandoned. For 60 years, the multi-chamber gun remained a failed experiment until August Coenders resurrected it. Coenders was a German engineer working for Röchling Iron and Steel Works in Saarbrücken. In 1941, he proposed solving the premature ignition problem with electrical firing. Install electric fuses in each auxiliary charge. Fire them in precise sequence as the shell passed. This eliminated the gas propagation problem. The shell would trigger sensors. The sensors would activate fuses. The charges would detonate at optimal timing. Coenders built a 20mm prototype at the proving ground at Mizdroy on Wallen Island, Poland. Testing began April 1943. The prototype worked as the charges fired in sequence. The shell accelerated, but performance was inconsistent. Sometimes the shell reached high velocity. Sometimes it tumbled. Sometimes it broke apart. The concept required development. Coenders needed funding. He found an advocate in Armaments Minister Albert Speer. In May 1943, Coenders briefed Speer on the multi-chamber gun. Speer was enthusiastic. Germany needed weapons to retaliate against Allied bombing. The V-1 flying bomb was under development. The V-2 rocket was progressing. A third Vengeance weapon would demonstrate German technological superiority. Speer arranged a meeting with Adolf Hitler. On May 4, 1943, Coenders briefed the Führer. Hitler was fascinated. He loved artillery. He loved big guns. He loved weapons that could bombard cities. The multi-chamber supergun combined all his obsessions. He authorized immediate development. The weapon received the code name Hochdruckpumpe, high pressure pump, HDP for short. The name was deliberately misleading. It suggested industrial equipment, not a weapon. Security was absolute. The project was classified above top secret. Even senior military officers were excluded from briefings. Hitler wanted this weapon operational before the Allies realized it existed. Construction was assigned to Organization Todt, the paramilitary engineering organization responsible for building Germany's fortifications. A site was selected near Mimoyek in the Pas-de-Calais region of France, 8 kilometers from the coast, 165 kilometers from London. Perfect range for the supergun. The final V-3 design specified the following characteristics. Caliber, 150 millimeters, 5.9 inches. Barrel length, 130 to 150 meters depending on configuration. The operational guns would be 140 meters, 460 feet. The barrel was constructed in sections. Each section was 4 to 5 meters long, T-shaped. The vertical portion of the T was the main barrel. The horizontal portions were auxiliary charge chambers, 32 auxiliary chambers per barrel. Each chamber contained a solid fuel rocket booster. When the shell passed, the booster would ignite. The shell would receive additional thrust. The projectile was fin stabilized, 140 millimeters diameter, 1.4 meters long. Weight, 140 kilograms, 309 pounds. The shell was arrow-shaped, 4 fins at the rear. The design provided stability at supersonic velocities. Theoretical muzzle velocity, 1,500 meters per second, 4,921 feet per second. Range, 165 kilometers, 103 miles. Flight time, approximately 90 seconds. The shell contained 20 kilograms of high explosive, small by artillery standards, but 600 shells per hour would deliver 12,000 kilograms of explosive daily. Sustained bombardment would devastate London. The installation at Mimoyekes was extraordinary. 2 parallel complexes, each containing 5 drifts. A drift was an inclined tunnel excavated into the hillside. Each drift was 138 meters long, inclined at 50 degrees. 5 gun tubes per drift. 25 guns per complex, 50 guns total. The drifts exited through a concrete slab 30 meters wide and 5.5 meters thick, 18 feet of reinforced concrete. Steel plates protected the 5 openings. Each drift had armored doors. The guns themselves were fixed. They could not traverse. They could not elevate. They were aimed at London during construction. Once built, the alignment was permanent. Accuracy depended entirely on consistent shell performance. Below ground, the complex was massive. 2 railway tunnels 100 feet underground, 650 yards long. The tunnels connected ammunition storage galleries to the gun chambers. Conveyor systems would transport shells from storage to the guns. Approximately 1,000 troops from Artillery Abteilung 705 would operate the facility. The garrison would include gunners, loaders, maintenance crews, security forces, and administrative personnel. When operational, the complex would function as an underground fortress, self-contained, defendable, capable of sustained operations regardless of surface conditions. Construction began September 1943. Organization Todt mobilized 1,200 to 1,500 workers. Some were German engineers from Schachtbau and Tiefbohr, a company specializing in underground construction. Most were slave laborers, Frenchmen, Italians, Russians, Poles, forced workers from concentration camps and prisoner of war facilities. They worked 12-hour shifts, excavating chalk, installing structural supports, laying rail lines, pouring concrete. The conditions were brutal. Injuries were common. Fatalities occurred regularly. No one cared. The work had to be completed. Hitler demanded it. The technical challenges emerged immediately. Coenders, working at Hillersleben, proving ground near Magdeburg, encountered severe problems. The multi-charge propulsion system was extraordinarily complex. The shell had to pass through the barrel at precise velocity. Too slow, and the auxiliary charges would push it unevenly. Too fast and timing would be impossible. The charges had to ignite at exact intervals. Milliseconds mattered. The sensors detecting the shell had to be reliable. The electrical firing system had to function flawlessly. Any single failure would cause catastrophic malfunctions. Shell design was equally problematic. The projectile had to be aerodynamically stable at supersonic velocities. It had to withstand acceleration forces from 32 booster charges. It had to carry sufficient explosive to be effective. It had to be manufactured in quantity. 6 different companies attempted shell designs. None achieved acceptable performance. The shells tumbled. They broke apart. They veered off course. By December 1943, no reliable shell design existed. Barrel wear was catastrophic. The 32 auxiliary charges created extreme thermal and pressure stress. Each firing eroded the barrel significantly. Tests at Misdroy demonstrated that barrels failed after approximately 25 rounds. This was unacceptable. Operational requirements specified sustained fire for hours daily. Barrels would need replacement constantly. No mechanism existed for replacing barrels built into mountainsides. Once installed, the guns were permanent. If the barrels wore out, the entire installation would be useless. Obturation was another failure. Obturation is sealing the breech to prevent gas leakage. In conventional guns, this is straightforward. In multi-chamber guns, each auxiliary charge chamber creates a potential leakage point. Gas escaping through auxiliary chambers reduces pressure. Performance degrades. Co-enders attempted various sealing methods. None worked reliably. Gas leakage remained problematic throughout testing. Despite these failures, construction at Mimoyeques continued. Hitler had ordered it. Speer pushed it. Organization Todt executed it. By March 1944, the eastern complex was substantially complete. 5 drifts excavated. Concrete slab poured. Steel doors installed. Railway tunnels functional. The guns themselves were not yet installed. Components were still being manufactured. Testing continued at Misdroy and Hillersleben, but the infrastructure was ready. Hitler expected the first battery operational by March 1944. Full complex by October 1944. 600 shells per hour. London under sustained bombardment. German vengeance. But the Allies were watching. In late 1943, reconnaissance aircraft photographed unusual construction at Mimoyeques. Analysts studied the images. Massive excavations. Rail lines. Concrete work. The activity suggested a major installation. Purpose unknown. The site was added to target lists. In November 1943, Royal Air Force bombers attacked. Damage was minimal. The concrete slab protected the underground works. But the Germans now knew the British were aware. Security had been compromised. Additional raids followed. The United States Army Air Forces attacked in December 1943 and January 1944. Again, damage was limited. The site was heavily defended. Anti-aircraft batteries surrounded it. Smoke generators obscured it during attacks. The concrete slab was incredibly thick. Conventional bombs could not penetrate. The installation seemed invulnerable, but Barnes-Wallis had designed a weapon specifically for such targets. The Tall Boy was not a conventional bomb. It was an earthquake bomb. The concept was revolutionary. Rather than destroying targets with blast effects, the Tall Boy penetrated deep underground before detonating. The explosion created a camouflage, a cavity. The target structure would collapse into the cavity, or the shockwave would destroy foundations. The weapon worked like an underground earthquake, hence the name. Wallace had designed the Tall Boy in 1942. Initial proposals called for a 10-ton weapon. The Air Ministry rejected this. Too large. No aircraft could carry it. Wallace scaled down. The final design weighed 12,000 pounds, 5 long tons, 5,443 kilograms. This was within the payload capacity of modified Lancaster bombers. The Tall Boy specifications were precise. Length, 21 feet, 6.4 meters. Maximum diameter, 38 inches, 0.97 meters. The bomb body was 10 feet 4 inches long, 3 feet 2 inches diameter. The tail assembly was 10 feet 8 inches long, aluminum construction. The fins were twisted slightly. This caused the bomb to spin during descent. Gyroscopic stability, improved accuracy. The casing was cast from a single piece of high tensile steel, 4 inches thick at the nose. Total weight, 11,855 pounds. Of this, 5,200 pounds was Torpex explosive, a mixture of RDX, TNT, and aluminum powder, more powerful than conventional explosives. The Tall Boy was dropped from 20,000 feet. It reached terminal velocity during descent, 750 miles per hour, 1,200 kilometers per hour, faster than sound. The bomb struck the ground supersonic. At impact, it penetrated through soil, rock, or concrete. The hardened steel casing withstood enormous forces. The bomb burrowed deep, 20 to 60 feet depending on soil conditions. Then it exploded. The detonation occurred underground. All explosive energy transferred into the surrounding earth. The shock wave propagated through rock and soil. Structures within the shock wave radius collapsed, or subsided, or simply disintegrated. The effectiveness had been proven. On June 8th to 9th, 1944, Tall Boys were used against the Saumur railway tunnel in France. One bomb penetrated the hillside and exploded inside the tunnel 60 feet below the surface. The tunnel collapsed completely. German panzer reinforcements could not reach Normandy. The invasion proceeded. On June 24, 1944, tall boys attacked the V-2 assembly bunker at La Coupole. Near misses undermined the foundations. The bunker was abandoned, never used. The tall boy was the weapon Germany feared most, and Mimoyekes was the perfect target. On July 6, 1944, 16 Lancasters of No. 6, 1-7 Squadron departed England, the Dambuster Squadron. Veterans of the 1943 raid that breached German dams, they carried 16 tall boys. The target was Mimoyekes. Weather was poor. Cloud cover was heavy, but the raid proceeded. The Lancasters climbed to bombing altitude. Wing Commander Leonard Cheshire flew ahead in a Mosquito. He identified the target through breaks in clouds. He marked it with pyrotechnics. The Lancasters approached. The bombardiers aimed carefully. Tall boys required precision. Miss distance mattered. At approximately 13-15 hours, the first tall boy fell. Others followed. 16 bombs, 12,000 pounds each, 192,000 pounds total, 96 tons of explosive. The bombs penetrated the hillside. They exploded underground. The shock waves were enormous. Tunnels collapsed. Shafts caved in. One drift completely destroyed. 300 workers killed, buried under thousands of tons of rock and concrete. The complex was devastated. German engineers assessed the damage. The eastern complex was unusable. One drift destroyed. 2 others severely damaged. Repair would take months, maybe longer. The western complex had not yet been started beyond initial excavations. Hitler's plan for 50 guns was impossible. Speer authorized continuation with reduced scope. 3 drifts, 15 guns. This was optimistic. Testing at Misdroy continued to produce failures. On April 1944, after only 25 rounds, the test gun failed catastrophically. The barrel cracked. The propulsion system malfunctioned. The project was suspended pending resolution of technical issues. By late July 1944, the situation was hopeless. Allied forces advancing from Normandy were approaching the Pas de Calais. The front line was collapsing. Mimoyekes would be overrun within weeks. On July 30, 1944, construction was officially terminated. Workers were evacuated. Equipment was removed. The complex was abandoned. Not a single operational shot had been fired. Not one shell had been launched toward London. The V-3 supergun existed only as empty tunnels in a French hillside. But Hitler was not finished. In December 1944, during the Ardennes offensive, 2 shortened V-3 guns were deployed near Lampaden in the Saarland region of Germany. These guns were approximately 50 meters long, 1/3 the length of the Mimoyekes guns. They were surface mounted, not buried. They were aimed at Luxembourg City. Range, approximately 60 kilometers, 37 miles. The guns entered service December 30th, 1944. They were operated by Artillery Abteilung 705. The unit that had been training for Mimoyekes between December 30th, 1944 and February 22nd, 1945. The Lampaden guns fired 183 rounds. Approximately 140 shells struck Luxembourg City. 10 civilians were killed. 35 were wounded. The damage was minimal. The shells were inaccurate. The guns were unreliable. Barrel wear remained catastrophic. After approximately 90 rounds per gun, the barrels were unusable. No replacements existed. The guns were abandoned. Allied forces overran the position in March 1945. The V-3 program was over. Post-war analysis examined what went wrong. The multi-charge propulsion concept was theoretically sound, but execution was impossible with 1940s technology. The timing precision required exceeded available electronics. The sensors were unreliable. The electrical firing systems malfunctioned. The shells were unstable. The barrels could not withstand the thermal and pressure stress. Every element of the system was marginally functional at best. Combined, they produced a weapon that barely worked. The strategic assumptions were equally flawed. Hitler believed sustained artillery bombardment would break British morale. This was incorrect. The Blitz had proven British resilience. V-1 flying bombs and V-2 rockets were killing thousands. British morale remained high. Adding artillery bombardment would change nothing. The resources expended on the V-3 could have produced more V-1s or V-2s, or tanks, or aircraft. Anything would have been more useful than a gun that did not work. The cost was enormous. Exact figures are unavailable, but estimates suggest tens of millions of Reichsmarks, thousands of tons of steel and concrete, 1,200 to 1,500 workers for over a year, slave laborers who could have been building defenses elsewhere, engineers who could have been improving functional weapons. The opportunity cost was devastating. Germany was losing the war. Resources were scarce. Every ton of steel mattered. Every engineer mattered. Wasting them on wonder weapons that did not work accelerated defeat. The human cost was significant. 300 workers died when tall boys collapsed Mimoyeques. Hundreds more died in accidents during construction. Slave laborers worked 12-hour shifts in brutal conditions. Many were injured. Many died from exhaustion, malnutrition, or disease. Their sacrifice accomplished nothing. The guns never fired. The complex was abandoned. They died building a weapon that failed before completion. The British response demonstrated Allied superiority in multiple domains. Intelligence detected Mimoyeques despite German security measures. Reconnaissance identified it as a threat. Analysts determined it was a V-weapon site. Planners prioritized it for bombing. Engineers developed weapons specifically to destroy it. The tall boy was designed for exactly this mission. Number 617 Squadron executed perfectly. 1 raid, 16 bombs, complex destroyed. The entire chain, from intelligence to destruction, functioned flawlessly. Contrast this with German incompetence. A weapon was authorized before testing was complete. Construction began before technical problems were solved. Resources were committed to a system that barely functioned. When testing revealed catastrophic failures, construction continued anyway. Hitler demanded it. Speer pushed it. Engineers knew it would not work. They built it regardless. This pattern repeated throughout Germany's wonder weapons programs. V-1 flying bombs were unreliable. V-2 rockets consumed enormous resources for minimal effect. The V-3 never worked at all. Germany was losing the war building weapons that did not function. Today, Mimoyeques is preserved as a museum. The site opened to the public in 1984. Visitors can walk through the tunnels, see the collapsed drifts, examine reconstructions of the gun sections. Displays explain the multi-charge propulsion system. Photographs show the construction process. Memorials honor the slave laborers who died building it. The site is a monument to futility, a testament to how desperation produces delusion. The museum displays include a scale model V-3, approximately 1/10 actual size. The model demonstrates how the system was supposed to work. Visitors can see the barrel sections, the auxiliary charge chambers, the shell, the electrical firing system. Everything looks functional. The model works, but the actual guns never did. The gap between concept and execution was insurmountable. Fragments of the actual guns survive. When Organization Todt evacuated Mimoyeques, some components were left behind. British troops found barrel sections, auxiliary charge chambers, shells, fire control equipment. Some pieces were shipped to Britain for analysis. 2 barrel sections are displayed at Fort Nelson in Portsmouth. They are approximately 4 meters long, T-shaped. The auxiliary charge chambers are visible. The electrical connectors are still attached. The steel is corroded, but the engineering is evident. These sections were part of Hitler's London cannon. They never fired a shot. The legacy of the V-3 is cautionary. It demonstrates what happens when political demands override technical reality. Hitler wanted a supergun. Speer promised to deliver it. Engineers said it could not work. They were ignored. Construction proceeded. Resources were wasted. The weapon failed. This pattern characterized much of Germany's late war production. Wonder weapons that promised salvation but delivered nothing. Jet aircraft that could not get spare parts. Submarines with advanced technology but insufficient numbers. Rockets that consumed resources but achieved minimal strategic effect. All were symptoms of the same disease. Desperation mistaken for innovation. The V-3 also demonstrates Allied technological superiority. The tallboy bomb was revolutionary. It worked. The V-3 was revolutionary. It did not work. British engineers solved problems. German engineers could not. Barnes-Wallis designed weapons that functioned. August Coenders designed weapons that failed. This disparity determined the war's outcome. The side with functional technology won. The side with non-functional wonder weapons lost. At 1300 hours on July 6, 1944, 16 tall boys destroyed Mimoyeques. Hitler's London cannon died before it lived. The 430-foot guns would never fire. The 600 shells per hour would never fall on London. The vengeance Germany sought would never be delivered. The tall boys ensured it. 16 bombs, 16 impacts, complex destroyed, 300 workers killed. The V-3 was over, a weapon so ambitious it defied engineering, so complex it could not function, so expensive it wasted resources Germany desperately needed. A supergun that never shot. That was the V-3, Vengeance Weapon 3, the London cannon, the high-pressure pump, the gun that was 430 feet long, buried in a mountain, aimed at London, designed to fire 600 shells per hour, supposed to devastate Britain. never fired an operational shot, destroyed by 16 bombs before completion. The ultimate German wonder weapon, the weapon that demonstrated how wonder weapons lose wars. The V-3 existed for 22 months, September 1943 to July 1945. It consumed millions of Reichsmarks, thousands of workers, hundreds of engineers, tons of steel. It produced 183 shells fired at Luxembourg, 10 civilians killed, and empty tunnels in a French hillside that tourists now visit to marvel at German delusion. That was its legacy, a monument to futility, a testament to how desperation produces failure. The gun that was supposed to save Germany, that could not even fire.